Okay, so we're gonna get started. This is the 0th edition of the board design weekend. So I chatted on Twitter a little bit back about designing some boards. I have some like crazy ideas pretty regularly for boards that I want to design. I've also got crazy hair. Welcome to Sunday. I hope it's not apparent I only woke up like an hour ago. But yeah, so the idea is that I'm going to design some of these boards, maybe one a weekend, or put some work into them once a weekend. And then at the end of each month, I'm going to pick one and get it made. This way, I'm not ordering every crazy idea that I have, and I at least have some time to reflect on them. And yeah. So since it's the last day of February, which means it doesn't really fit well into my board design thing, and I've never done this before, and I don't super know what I'm doing, for this one, I think I'm actually going to try something different. I think I'm just going to design a really simple board that I know that I can get done in one day, or I think I can get done in one day. And I'm just going to go ahead and order that just to show how the process goes. So I'll start from like a completely brand new KiCad project to ordering on JLC PCB. At least that's who I typically use. In the future, I may also want to try someone like Euler. I'm in Europe, so Oshpark doesn't make a ton of sense for me, but maybe I can try Oshpark just because they have those really cool After Dark boards. Yeah, so I'm going to design a really simple breakout, go through the whole process, see how long it actually takes me, so I have a sense of should I be breaking this up into like 2 episodes per board or something like that. And yeah, we'll just see how it goes. Today I'm going to build a so the couple things that I was trying to figure out what I wanted to do. I wanted to design a simple board. I wanted to design a board with no SMT parts. So services like JLC PCB also do assembly for you, which I use for a lot of the projects that I work on. I probably have something here in my drawers of something that I have built that has are there no parts? Did I clean this up entirely and I don't have boards anymore? Here we go. So, I mean, I've done boards that are just like basic breakouts. Like I did this little Lego breakout board here. That's just like a little breadboardy kind of thing with some room for quick connectors. I've also done slightly more complex things that do have some parts assembled on them. This is for my Anacro project. But yeah, for this first one, I wanted to do something that didn't require assembly, just because I don't want to go hunt down parts and stuff like that and figure out what parts I'm going to use. So what I'm going to do today is I'm going to build a breakout for the STM32F4 Black Pill, which is a really common dev board. You can get them for like $3 or $4 on AliExpress or eBay or whatever. And they're a nice little breakout board. Like if you need USB and some pins, they work really well for that. They run at like 96 or 100 megahertz. Like I said, they've got USB-C. They don't do power delivery or anything, but they've got some room for some stuff. They've even got some room for like a QSPI flash or something on the back. They've got debugging headers broken out. They're a good like chuck it in a project if you need a microcontroller kind of board that's, not the cheapest, but also has a decent amount of power. So I use them for a bunch of stuff. You've probably seen me use it on my keyboard and stuff like that. And what I typically do, let's see if I can do this without disturbing. Can I do this? I mean, what I usually end up doing is I end up building like on a breadboard or a proto board or something like that. I end up building like a big breakout, and it involves a lot of wiring, and it's a pain in the butt, especially when I'm just like, I need an SPI port or I need an I2C port because I'm developing something. So I actually have something else I'm building called the Nerling test adapter, which has it's sort of an STM32F4 breakout, but it's got a couple extra things on there. It's got a lot of extra stuff on it, and I don't think I necessarily want the extra stuff for this. So I think I'm going to make basically like a really simple version of this Nerling test adapter where the Black Pill can sit on top, and it's going to have little Lego mounting holes like I did with that other board I held up a second ago. Because I like mounting everything on Lego, because it makes cobbling together assemblies really, really quick. So I have a bunch for feathers, Adafruit feathers already. So I'm gonna do one for the black pill because that's probably the next most commonly used board format I have. I have a whole stack of them from ordering. Like I said, they're like $3 or $4 a piece. So I order them like 10 at a time, and then that way I can just chuck them in projects and leave them. So I'm gonna do this. I'm gonna do my STM32 F411 black pill. I guess it's FX1 because they sell a F01 as well. It's a little cheaper. It has different. I think it has less RAM and flash and stuff. It's only like 50 cents different. So for throwaway projects, I just buy the more expensive one because like 50 cents doesn't matter that much. It's $5 for every time I order 10. It's gonna have some Lego mounts. I might have a fancy. I'm gonna have some PMod pinouts or PMod-esque pinouts. It's gonna have maybe a fancy 12-pin connector idea. I have maybe some quick connectors, maybe a fancy debugger connector. We'll see. I'm gonna see what ends up making sense, and I don't know. I don't have a strong plan for this, so you get to be along for the planning and design process as well. Yeah. If you have any questions, feel free to ask them in chat. This will be recorded and published later, so thanks if you're watching this live, and thanks if you're watching this later. But I'm gonna go ahead and get into it. So let's bring up KiCad. I honestly don't know if it's KiCad or KiCad. I don't know. You'll have to deal with me. Let's go ahead and make a new project. Come on. New project. So I have this repo called BrickMount where I've been putting all of my little Lego enabled boards. So let's make a new one. This is going to be the STM32, or this is going to be the black pill breakout. So I got a new project, not much to it. It's totally empty now. There's a couple things I know I need to add. One of the first things I end up doing is adding my parts and libraries. So you can add existing parts. I don't think I'm going to design a new part today. I'll probably do that in a later stream, but I'll show you at least adding them if you've pulled them off the internet or something like that. KiCad's great because people share stuff like open source, including this brick mount stuff. So we'll go ahead and do this. My computer's gonna be running a little slower because I am streaming. I probably, well, I keep saying this. In the future, I'll probably move my bigger server PC in here and start doing that because it can probably handle streaming and CAD at the same time better than my laptop can, or I'll split it up so I have like a capture card or something. I don't know. We'll figure it out. Hopefully you can suffer through the slow process with me today. So this is just by default. It's got whatever I've got configured. I tend not to have global dependencies, so it's got nothing in it basically. So the first thing I want to do is I want to file, add library in the brick mount. In parts, I have my brick library, which has all of my like Lego footprints and stuff like that. So I'm gonna go ahead and add that, and I'm just gonna add it to the project. So now we can see I've got my footprints for that. I also have, I don't think I've added my everything repo here. I have a repo that has a bunch of random parts in it. Let me go find that and add that as a submodule to this project real quick. KiCad libs. Okay, so in CD hardware, let's make this bigger. Hardware, brick mount parts. Whose is this? It's someone else's. Git sub module add. I've got just like a KiCads library that I use. It's not well sorted. I wouldn't recommend doing my practices here. But it's gonna, I know it already has some of the parts that I want. So I'm going to add library, and in parts, KiCad libs, I've just got an everything library, and I'm gonna add that to the project. And the reason that I have that is because, oh, this doesn't have it. What did I do with my what I'm looking for is my my Blackpill footprint, which I have in another project. So let's go ahead, and don't actually need this in the project anymore, so I should probably remove it, but whatever, it's here now. I'm gonna open a project. Let me go find Nacro hardware rack module project. Okay, so this is another project that I have. This is actually the one, and it's probably complaining because I've moved stuff. That's going to be interesting. So this is actually the schematic for the board that I was talking about, so we can look at this in CAD. And like I said, I'm going to sort of steal a lot of the stuff from this. It's going to be like a really stripped down version of this. So I am going to steal this, and particularly the pinouts that I use for this. I've already figured out like how to get an SPI port, a UART, an I2C, and then a bunch of GPIOs to headers in roughly PMOD layout. So I am going to basically steal that. So what I'm going to do is I'm going to export this as a PDF. Let's put this in, where am I going to put this? I'm going to put this in my lab notebook. Lab notebook, source, notes, 2021. Let's see, this is KTA V2 schematic. And let's just print that to PDF, because I'm going to come back to that as a PDF. And then I do want to figure out where this comes from. So where did I put this? USB-C pill WEACT. Hardware USB-C pill does not exist. Okay. Okay, that's certainly a thing you've chosen to do. Discard changes. Okay. Now we get to go on a cconfine for I guess this lives here. I should probably just move this into my everything repo. CD KiCad libs. CP hardware archive USB-C pill.zip here, and then Nautilus here. What if I just unzip this? USB-C pill. It's got the lib and it's got the pretty in this. Okay, I can live with that. Before I commit this, okay, let's go back and open up our Blackpill breakout. And let's go to our footprints, or excuse me, this is symbols. So KiCad breaks up things into symbols, which are like schematic stuff, and then footprints, which are like circuit design stuff. So KiCad's let's see in my USB-C pill. Let's see if I open this to the project. If I have a USB-C pill. Okay, cool. So this has all the pins on it. Excellent. Now I need to go into my footprints, and I need to add a library, which is in parts, KiCads, USB-C pill, USB-C pill pretty. Add that to the project. Now I should also have USB-C pill with pinouts. Lovely. So, okay, so that's good to go. So let's go ahead and I also need to, because you are a submodule, git remote add sh this rm usb-sil.zip git add -I add all this stuff. So let me origin main. No, git push sh main. I probably need to not have my, there's probably a couple things that I do not need to have here, but whatever. Yeah, again, I wouldn't recommend this Git repo. Don't take my organization stuff here, but it does work. Okay, cool. So we have our parts. So usually what I do when I'm figuring out what I want to do is I actually usually just start in the schematic. And I'm going to sort of like figure out what I could fit in here. So I'm just going to start placing footprints. So let's go with our USB-C pill with the debug stuff. And let's see, we've got 1/4 millimeter grid, which is okay. So we're going to place this here, and let's see how big that is Lego-wise. So I'm going to add a brick. Let's add an 8. So I'm just going to place one of these. And let's copy this. And we're going to have another one of these. It's going to be roughly here. And then if I put one of these like here, I can sort of figure out what kind of space. I think I'm going to have the connectors at the end rather than at the side, just because that tends to work well with what I do. Because then the USB connector can kind of just like stick out over the Lego pieces. Yeah, Git does have an interactive mode. Yeah, I use that all the time. I don't use a lot of GUIs for Git, but I do use the interactive mode all of the time. I'll pour myself some more coffee. And I'm actually going to put on some low background music just so you don't hear my pauses as much. That's not super chill music. I just got like music from Louis Zong. I don't know. Let me know if you like the music or not. I'm gonna try it a little bit. But yeah, I've got to figure out what I want to do here. It looks like I'm probably gonna want something that's like maybe 6 long. I can try working on that, and then maybe if I do 6 by 10, basically, you can see if that gets me going. So I'm going to get rid of this, and I'm going to move this out of the way a little bit. And then let's place a 6 here, 1 by 6, and we're going to try and center this. I don't know how far this is going to be. Let's try putting this roughly here. And then let's move this so that it's just clicking up together with this. Come on, grab the center. And then this, and then... So these ones on the side aren't going to really exist. They're going to go away. I'm just kind of using them for spacers right now. So I've got this. So this is like 10 big, which might be enough. Well, let's start with it for now. I am going to want you to kind of butt right up against the edge of this. Because like I said, the USB port's going to be sticking out this direction. So I do want this to be pretty close to flush, just so I'm not like wasting a lot of board space. So what am I going to want? I'm going to want a couple PMod things. So I'm going to place... See, I remember I had about 6 PMods on there. So let's go to pin socket 1 by 06 vertical. So this is just a nice little, like, you know, 6-pin header. And I am going to get rid of actually these first because these don't need to be here. And let's go ahead and place a... I'm going to start drawing my board outline now, just so I sort of remind myself to paint inside the lines. I usually try and bring these in about a 0.5 millimeter, just so that the Lego pieces snap together. So usually, even though I'm going to do rounded corners, I typically just do a rectangle first, and then I add the arcs afterwards, and you'll see how that goes. Okay, so now I can place an arc, and then let's bring this in 1, 2, 3, 4. So that's 1 millimeter. Can I do 1.5 millimeters? I could probably go further. So that's a 2 millimeter. Yeah, that's gonna be fine. So then what I usually do is I just grab this, put it there, rotate it. This way I know that I get exactly the same size and I don't accidentally mismeasure this. And then I just pull these lines back so that they meet the curve. Okay, so that's a board outline. I can live with that. I don't know if I'm going to want this to be centered. I mean, I don't really have a great reason for it to be centered. If it was easier to move all the stuff over to one side, I might. But right now we've got a nice, delightful little 6 by 10. So what is this? This is what? I guess 80 centimeters. And 6 is going to be 48, so it's 48 by 80, give or take. So I want to place I'm going to be pacing. And, oh, that's not what I want. I admit, if you are a PMod aficionado, that there is a specific spacing you're supposed to have for PMods if you put multiple on there, and I'm going to admit that I'm not going to do that, and I apologize to the PMod standards body. But, you know, what are you going to do? And this won't be quite right, because these are aligned to... Actually, you know what? I'm going to... let's sort this out over here. So one of these tricks that I like doing for mixing imperial and metric is you go and you do an imperial grid somewhere else. You kind of place this on the imperial grid, and then 1, 2, this would be directly touching. So let's 1, 2, this is a gap of 1, 1, 2. So this is a gap of 2 pins basically. So 1, 2, 0 pins, 1, 2, 1 pin, 1, 2, 3 pins. So this is, let's just real quick, how this fits on the board. Is this gonna fit? Oh yeah, that's gonna fit pretty comfortably. I think that's what we're gonna do on both sides. I may end up having like 3 rows of them, because what I think I want to do is I want to have just like almost like a proto board header style of them, where like these 3 are all connected. Okay, so that actually looks pretty okay in my opinion. And again, I know these aren't going to be correct, but I'm basically going to throw this whole thing away anyway once I'm done sort of prototyping. I think that's roughly aligned. Okay, so I can have like my GPIOs and my whatever and my whatever. So these are all broken out, and that's delightful. The other thing that I want to see is there is a sort of like everything pinout I'm planning on using for some of my boards. So let's try and place one of those. That's just going to be I think it's just another 2x12. Pin socket 2.5 vertical. Nope, not 2x12, 2x06. 12 pins total. Let's see, you're gonna be over here or something. I don't know. Place footprint, and then I want a 2x04 pin header. I'm just kind of like throwing everything on here, and we'll maybe throw some stuff away, but we'll figure it out. And then the sort of crazy thing is I've been thinking about using Ethernet as an SWD long cable, basically. So I'm going to try placing a footprint that is... What do I want? I want an Ethernet connector, RJ45, RJ45. And there's a specific one that I use that is... Let's see, I ordered these, but I don't have the bag for it anymore. I think it's like the cheap Amphenol one. So I think it's gonna be one of these Amphenol ones, and it's gonna be whatever the like dead simple. Oh, it might be this one. Oh, I think it's this one. Horizontal low latch connector mod jack. Yeah, I think this is our one. I want to see if I can fit this under here. Nope, I sure can't. Those mounting holes are going to be a problem. Where could I fit this? If I didn't have these connectors here, I could put it here, but then I couldn't. And the question is whether I want to do this as an external board. Because that's a chonky connector. I'd probably have to get rid of one of these. So if I took these and I moved them somewhere else. So I don't really need the whole thing to be on the board. Because I figure when I'm doing debugging, that's just going to kind of like stick. Let me see if I have one of these. Because I mean, like this dev board is sort of the same. I have a little breakout board here, for like a little SparkFun breakout board for RJ45. And I just use this as like generic 8-pin or 4x2 twisted pairs. So maybe I will try and get away with one less PMOD, basically. And maybe I'll try and sneak those pins in here. Let's go look at what this looks like in 3D. Ignore the magical floating pins off to the side. I think this isn't bad. I'll probably spread these out to be more reasonable. Maybe have some extra pins for like grounds and stuff like that. And maybe even like shadow the pins here. So if I really wanted to, or maybe like inside or outside shadow the pins. So that if I wanted to, you know, these are for prototyping. So I really just sometimes need to do absurd connector things. And sometimes I want it to be really easy. And sometimes I want it to be, I don't need it to be so easy. So I guess I could probably get this down to 4 wide, but it would make mounting it more challenging. So tell you what, I'm going to, let's get rid of this. I'm going to save, and let's go to, okay, so now I've got a checkpoint. So let's tear this apart. So what if I wanted to make this fit in a 4-pin format? So let's assume that I probably have to get rid of this. Probably have to move this. Can I even get this in a 4-pin? No, that'd be really tight, and there's no way I would be able to get that Amphenol connector in there. And I typically like doing even number of Legos just because the parts that I have are usually even, which means it's easier to build a mount on it. Okay, no, I can live with this. Yeah, we'll go back to what we had. So I think yeah, this is gonna be our winner. I can have 3 sets of pins on there, and they're just going to be common across them. I can have my weird everything 12-pin connector, which I'm planning to make like has one SPI port, has one I2C port, has that, and then this 8-pin where I'm thinking about doing programming, but I guess I probably don't need this one and this one. This I'm planning on using for a smaller board, where I just need like some kind of debugging header, but maybe I'll save that and be special to that board, but maybe I'll keep this as sort of like the grand unified connector over here. Anyone in chat have thoughts? I'm going to have let's go back to our 3D view. I end up using this 3D viewer like a ton. It helps me conceptualize what I'm doing circuit board wise so much better than like just a regular schematic does. I mean, I guess it's different. Like, So, I mean, I've got this. This is going to stick out, but that's okay. I guess ideally I'd want the... Like, ideally I'd want this to be, like, pointing in the same direction as the USB, because if I have it, like, coming out of a box or something like that, I probably want it to just, like, both the wires be sort of put together. But then I might lose the ability to do... Well, let's try it out. We're here. This is the last thing I'll try, and then if this is annoying, then... So let's try moving all of our good friend pin headers. No. Let's move these over here. Let's tuck you right up close here. And then we're going to want this to actually sit all the way inside of the footprint. You know, that's not actually terrible. Got some room for activities up here. I think the real question is going to be, how crazy is the routing going to be to here? And can I do that in a 2-layer board? Because especially in a 2-layer board, when you've got all of these, like... Through-hole components are the worst because you have to route signals everywhere. But I do like the idea of having the USB and the Ethernet cable pointing the same direction, because then I can just kind of like zip tie those two connectors together, and it makes it way less tedious. Although that does take up a lot of footprint on the board. Anyone in chat have opinions? Do they like style A or style B? Also, the problem is I'm going to have to kind of... This needs to talk to the debugging stuff, which means all this needs to come over here, which is going to be a nightmare. Well, these have the same number of connectors, so honestly, yeah, these have the same connectors, so actually I can sort of defer this problem for right now, because this is what I'm going to have. So I will stick with this. So the layout actually doesn't matter so much because it'll fit in either arrangement. So I'm going to go with this as my component list right now. And then I will think about how I want to arrange this later. Because once I can see the rat's nest or like where all these connections need to go, we can see if I can untangle this, or we can see if this is going to be, you know, egregious to try and route somehow. But I think this is looking pretty promising so far. So what I'm going to do is I'm going to save this. Okay, so now I'm gonna, let's go update my, well, let's bring this back up. And I'm gonna send this over here. So I'm gonna take some notes. Post layout notes, post scratch layout notes. I'm gonna have the STM32F4 black pill. I'm going to have my Ethernet connector as debugger. Maybe I'll even make this a little bit more generic. We'll see. Let's not be too clever by half. I'm going to have 5x pmod headers. Probably 1x spy, 1x I2C, 1x UART, 2x GPIO, all pmods repeated 3x. I've got 1x 12 pin everything connector. What else do I have? Oh. Well, no, I think that's it. Oh, I'm going to have my 2x 1x6 mounting holes. I think that's everything I'm going to have. Okay. So I'm going to go ahead and close my... Oh, I might want some quick connectors. Common to I2C pmod. Probably on the bottom. So the nice thing about the pmod connectors is I can just stick them on the bottom sort of anywhere. Let's see where I can fit this. Footprint. JST, what is it? It's the SH vertical. No, it's not the vertical. I want the horizontal. SM04. So these is what the pmods look, or excuse me, the that's not gonna super fit there. I mean, worst case scenario, I can put them here, which is gonna be sort of awkward from the bottom, but not the worst thing in the world. But I could also put them like here, maybe. I don't know. Not a great place to put them. If I didn't have them, I wouldn't be too heartbroken. And I gotta be careful facing them in. I guess if I shrink these down to just one space in between these headers, I could probably get away with fitting one on each side. So maybe I'll put one like top or bottom. We'll see. If they get thrown away, they get thrown away. I'm not too worried about it. Okay, so give me 1 second and I'm gonna get started with the so I will be right back. Okay, so I'm just taking a peek at the schematic while I'm thinking. So I'm going to go ahead and close this out. And now I need to be in the schematic. And I'm going to bring this schematic over to the second desktop, and let's move this over here. Oh goodness, where has my board gone? Okay, so let's place a couple components first. So black, black pill, and I do want the one with the this. I'm gonna have some generic con 1/6. Do they have a 3/6? That would 2 by no. Okay, so I'm going to just say con. Let's move these. Just moving my labels a little bit because I'm going to stack these 3 wide. And let's place a no, not a simple place. Label. Doesn't seem like chat's super active today, so feel free to ask questions if you want. I'm happy to answer. Otherwise, I'm just gonna keep working. We'll place a graphical polyline. Let's draw a pretty box around this. And then I'm gonna have, let me place a wire before I copy and paste all this. The other thing I need to do is I need to set this footprint. Because if I don't do this, then I'm gonna have to do it manually. So it's nice to do stuff before you copy and paste. I'm looking for headers. Connector, header. Pin socket 254 06 vertical. Yeah, that has the right one. Okay, so now these all actually have their connectors. So now I'm just gonna connect these all. There's probably a nicer way to do this when I want like a common row of things, but this is the way I know to do it. If you know a better way, let me know. And we know that it does connect the middle one here, which is nice. So let me place some text pmod to do. So I know I'm gonna have 3 of these. So let's move these up here 2, 3, 4, 5. So we've got our 5 PMods there. I'm gonna have my fancy 2x06. I don't know what ordering I want. What do the PMods use? The PMods use 1, 2, 3, 4, 5, 6. Let's use counterclockwise. Place, label, I'm actually not going to need much here, so let's just copy and paste this. Then I need my RJ45. Let's see, and this has not shielded, which I don't think these are. Oh, alias. Okay, cool. So let's just use this. Let's leave some room over here because I have a feeling I'm going to need to do a little bit of extra stuff over here. This is the debug RJ45. Let's see, and then what else did I have? I had 5 PMods, repeated the black pill, the Ethernet connectors, one every connector. I got my mounting holes and my quick connectors. So let's place symbol. And I have not chosen my. I need to choose another couple parts. So your footprint is actually going to be the brick 1x6. And you are actually going to be mounting hole. And I don't know what I'm going to connect these to. I thought about connecting them to some signal. Or I could just connect them to ground. We can see. I'll leave myself some room. Okay, what else do I have? Oh, I have those, well, let's pick the parts for this now. I kind of like doing this as I go. Connector RJ45, Amphenol cheapo. You are my Amphenol cheapo. I'm pretty sure. You've been chosen. You haven't been chosen. I want connector pin socket 254 2x06 vertical. 2x06 254 vertical. Yes. Okay, so I think I should have all my parts then. So I'm gonna keep my naming scheme from some of this. And I'm gonna start wiring this up a bit. Place. Let's start with our power symbols. Plus 5 VO, or what do I have? Plus, it's probably just plus 5. Place symbol. Nope. Place power port. GMD. Three V3. Let's just connect these up. And then I'm gonna steal these. And mirror around the vertical axis. Yes. No, not a bus. Place a wire. And then I probably could no connect these because I don't really need these to also be connected. So what I'm gonna actually do, well, let's place them and I can bail on them if I need to. Nope. Okay, let's place some labels. So I don't think I'm going to connect my USB pins just because, well, let's get to it later. Place label. Okay, so B6 is going to be our I2C SCL. B7 is going to be our I2C SDA. And normally what I would do here is I would go to something like STM32 Cube MX, and I would pick my like what ports I'm using for what. But I've already done that for another project, so I'm just gonna trust myself from a while ago and hope that I didn't screw up anything. So if you're wondering how I picked these parts, it's me from another day. So A6 is by SIPO. A5 is by SOC. A4 is hash. By CS. Or what is it? How do you make it? Is it tilde? Yeah, tilde. A3 is USART RX. A2 is USART TX. A1 is USART RTS. And A0 is USART CTS. You are SWD reset. I've got no connects on those. I think these are like LEDs on the board already. I've got a bunch of other stuff, but that covers my I2C, it covers my UART, and it covers my SPI, which gets us started, and then we can figure out. GPIOs are a little bit more fluid. I don't really care which one they end up being. So let's start with this. So let's go look at our SPI. So you are SPI CS. You are SPI copy. And again, I'm trusting myself that I went and looked at the PMod spec on another day. There is actually like a spec document for PMods that you can go look at. I'm just using it as a, sort of convenient. You are actually going to go away because you are not labels, you're power labels. It is ground on top. And you are 3v3. Place wire. Okay, and then let's do PMod I2C. And I think on like all of these, this is just repeated. So pin 1 is gonna be I2C int, which I don't have allocated yet, and I2C RST, and then I2C SCL, and I2C SDA. Okay, let's do our UART next. So what do I have? I think I've got these two again. I don't know why I'm doing the wires first. UART, USART, CTS, USART, TX, USART, RX, USART, RTS. You're going to be PMod GPIO, GPIO 1. GPIO 2. Brick mount, haven't decided what I'm doing there. Here, everything connector, I haven't decided what I want to do. I do kind of just want to put everything here. Because the idea is that I can, like, just have one connector if I'm... So what would it take? I'm going to get rid of all of these. And I wanted... I don't think these are actually going to go here, but... I'm just sort of feeling out the connector right now. Need at least one ground and power. I guess I could get a UART on here. Somewhere, someone is yelling at me about signal integrity. And the fact that if I run these over a ribbon cable, they are going to crosstalk like absolute beasts. But you know, cost of doing business sometimes. Do I want 2 GPIOs or do I want more grounds? I guess GPIO, you can choose not to use one of these data ports. So what I'm probably going to end up doing is... I'm going to try and set things on opposing sides. So if you're only using I2C, you can at least ground the pin, and maybe there will be somewhat of a return path. It's not an ideal return path, but I guess ideally if you're not using everything at the same time, then you might be good. Do I want a 5 volt on there? I do want a 5 volt on there.
Pros and cons. I keep to myself most
Okay, so honestly, I might just leave it like this. No, I don't want 5 volts. I want another ground. Let's see. That's not terrible. I am gonna move this up here, and I guess the hope is just if you're using SPI, don't use USART at the same time, because I'm gonna have crosstalk like crazy. Ideally, these will all be grounded at all times. I think this is reasonable. Let me double check. There's like a 12-pin pinout that I was planning on using. I think it might have been the one from the Neotron, which is a project that I follow. I want to make sure there's not already a sort of standard that I can find here that, or at least I can be mildly compatible with something else, because once I use this once, I'm going to use it a bunch. GitHub.io Neotron. Yeah, that's what I want. Neotron BIOS? No, you are very broken. SPI, I2C, and dedicated IRQ lines. Where are your SPI? Hardware. Here we go. Let me show you what I'm looking at. So JP is working on this project called the Neotron, and he has like these, he already has these 12-pin expansion connectors somewhere. I guess here. I want to see if he has the... Well, I'll just clone this real quick. So let's save this. Other locations, computer or temp, Neotron hardware, KiCad project. Yeah, okay. Where's my expansion port? Expansion slot. So he's got Clock data reset. This isn't necessarily what I want. Similar. Chip select. I think I'm just going to make an arbitrary connector. I'm sorry, JP. I will probably regret this later, but... Can I do this? No, because he doesn't have room for UARTs. I just sort of want a UART. Just because they are handy. Okay, sorry, JP. Okay. So now I need to do GPIOs, but that's okay. Like I said, I'm going to probably do those last. And that's okay. I do want to wire up my debug connector. And I have a sheet for that. Okay, so you are going to be starting from pin 1. You're going to be ground. SWOT-IO. 3 is ground. SWO ground. SW clock. VT-ref reset. Okay, so place power port. So 2 is SWOT-IO. 4 is SWO. I don't think I've assigned yet. SWO 5 ground. You're going to be SW clock. You're going to be 3v3. And then, no, that was 7. 6 is SW clock. And then 8 is reset. So what did I call that? I called that like SWD reset inverted. And SWO I might actually want to break out as a switchable, because it might be nice to just power it over 5 volts as well. But because I can't remember, there was some reason that I couldn't use SWO on this board, but I don't know if it's just something particular that I chose. So maybe I will actually let's open up STM-Cube and let's see what it says about SWO. All right, we're gonna give this a second to migrate. I'll be right back.
Is it leaving this for the open air and singing songs to ward off the bears? Well, if it is, I will follow you there. Oh, honey, what's on your mind? Oh, honey, I see the signs that you decide past highway signs. The weight of the world, though you wanna fly by and by. I will follow you there.
Okay, I went quiet there. I finished up some of the schematic stuff. I don't think you missed anything. Mostly just organization and moving things around. I think the biggest thing I added were the quick connectors and the through-hole I2C pinups in case I need them. Sometimes the boards have them already, sometimes they don't. So I'll just leave a do not populate pad there. So if I really need to add some resistors, I can add some resistors really quickly. Yeah. Okay, so I haven't done any of my GPIOs yet, but that's okay. I'm going to go ahead and start routing this and see how bad it is, and then we'll see what I want to do for my GPIOs. It definitely seems like SPI is at the top, UART is at the top, and I2C is going to be at the bottom. We'll see where we go from there. So what I'm going to do is I've saved this now, and I'm going to go back to my schematic. And I'm actually gonna just delete everything because it's easier. I'm going to update PCB from schematic, and it's gonna want to annotate all the parts and give them numbers, and it did. And so now it gives me all the parts in a big jumble, which is vaguely useful. So let's go back to my quarter mil. Not quarter mil, excuse me. Let's go to millimeter. Let's put this right smack dab in a millimeter. And just for funsies, I'm going to place my 8-pin as a spacer. Let's put this there, and then I can get rid of this. And then let's put my line. Let's put our edge cuts back. Give me back my quarter millimeter. Let's put that there. And then I was going to put this roughly here, so let's scoot this right up to the edge. Let's tuck this underneath it. We can see these white rat's nest wires, which is lovely. And I need to figure out which of these connectors go with each other. So I'm going to switch this now to my... You seem to be following you. Nope, you are something else. So I'm just kind of putting these all next to each other. Wish KiCad was a little bit smarter about this, but, you know, we figured it out. So what did we say? We said that Spy on the left, UART on the right. So it looks like you all are... let's put you somewhere roughly in this region. And I think you might be the UART. Or maybe you're the spy. Yeah, you're the spy. You're the UART. Okay, and then these ones that are connected to nothing, we know are basically, well, one of them's going to be the I2C1. So you are connected to some stuff, which makes me think, and you are connected to the... I think this maybe needs to be this orientation. And then you're going to be our GPIOs, so you're going to be like here-ish. And you're gonna be here-ish. I'm gonna go real quickly look. Okay, so on the top they're on the left, and on the bottom they're on the right. P1 left. Yeah, okay, cool. So I'm still in my correct grid. So what did we say? We were going to try and fit these in 1 pin spacing. So that's 0. That's 1. You don't look aligned. Let's make sure this is on a grid. Okay, you're on a grid now. You look unevenly spaced. Let's make sure you're evenly spaced. You should be basically touching. Yes. One, two, 1, 2. One, two, 1, 2. One, two, 1, 2. Let's see. Let's center these. So these are all evenly spaced, so I can center them. Let's center them with the edge of the board. So what I'm going to do, this is my trick for switching easily between metric and imperial, is I place them all in imperial, and then I cut them and do it on a grid, and then let's find, then we switch to 1/4 millimeter spacing. Actually, let's just do millimeter right now because I don't need that much accuracy. And this is 72, which is going to be 36, which means my paste point is going to be at 36. So right on this line, so I'm going to place, I'm going to go to my drawings user, place line, and I want it right on 36, which is right here. So that's my halfway mark. Then I can paste. And let's do this. No, I do want to go back to 1/4 millimeter. Okay, so this is 1, 2. This is the edge of the board. Well, this is the edge of the board. That's half 1 millimeter, 1.5. Let's stick with this. So that's nice and centered. I could probably expand those out. The question is, could I get it aligned with this? Do I like this? Maybe. Now the trick is going to be to find something that is a multiple of 2.54 here. Now I'm wondering if I should have stuck in metric. Yeah, I'm going to do that. I am going to align here. It's a pain in the butt switching back and forth between metric and imperial. What's my rough spacing here? Um, 1.8, so I might just have to do some shenanigans here. We're gonna get this pretty close.
I can still see you all curled up in the sunbeam, poking around at all my keys and guitars. You've been cooped up inside this tiny little apartment.
Okay, so you are a multiple of 0.1 inches, which is lovely. So you could theoretically fit on a breadboard if I really wanted you to. 6 tall. How big are my breadboards? Well, I guess the whole point of this is that I don't need a breadboard for this. So this is the breadboard, so maybe it's less important than I think. So this is also 6. 12. Did I do the close? Okay, so this will fit exactly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This may not actually fit on a breadboard. I don't really need a breadboard. It is a breadboard. Okay. Okay, I'm gonna live with that. That's good enough for now. I might tweak these locations later, but I also might put some like extra schmutz here. Whatever, that's close enough for now. Grid 1 millimeter. Oh, I need to switch. This looks weird. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4. Why are you still showing in inches? I do not want you in inches. Quarter millimeter, place, arc. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, it seems like I spend a lot of time placing my connectors, and that's just generally to make the rest of my work easier. If they're in a fairly reasonable location, then it makes it not so bad to do stuff later. Okay, so now the next thing that I'm going to do is I'm going to place a ground plane. I'll probably initially start with a ground plane on the bottom. We'll see what I do on the top. I may fill that, but yeah, I don't know. We'll see. So, oh, non-copper zone. Nope. Let's make at least the back layer. You're going to be connected to ground. You have thermal reliefs. Yes. Okay, so now we have a ground plane. So hopefully some of our rat's nest wires go away. Now I'm just gonna start drawing some lines. Hopefully I've made it decently easy for myself and it doesn't require too much working, but yeah. Let's just start drawing some lines. I'm just gonna kind of move you a little bit closer. Nope. That tight. Let's leave it like that for now. And then immediately splitting my ground plane. And I don't know why I have fill ground plane on. Can I get this so that these are all perpendicular where they cross? I probably can. And I'm just doing this so I have less things traversing the ground plane.
damned, I'll be okay. I used to think I'd wanna be a bird of paradise, but now I'm happy being
Because now
just
I
a
only
quail.
have like a little slice through the ground plane
Used to think
instead of a
I'd
big
wanna
slice.
be a bird of paradise, but now I'm happy being just a quail.
See, this is again sort of.
You've got all your dances and your colors,
Please hold looking at Twitter.
while I'm over here just tripping on my own feet.
Okay.
Can't fly all too well, well it's not so hard to tell. I don't got the moves, but I'm bobbing to my own beat. I used to think I'd wanna be a bird of paradise, but now I'm happy being just a quail. I used to think I'd wanna be a bird of paradise, but now I'm happy being just a quail.
Let's see. So these are the 4 signals that I need, and they are roughly annoyingly non. See, these 2 are the. Tell you what, let's keep these down a little bit. What is this? Let's see, who are the cut unders? RX is gonna need to cut under. So it goes CTS. So let's go find our CTS and let's get rid of you. And let's have something like that. You're gonna be the furthest out one. And who's up next? TX is up next. Don't want that. I want it like this. And then RX is gonna have to jump. So actually, TX should jump. And RX should come down. RTS needs to make it the furthest, so RTS should be on the inside. Okay, so we got 2 sets of pins wired up, and I'm going to ignore the power stuff for right now. I could probably also pull this stuff down a little bit in case I need to run something, but let's see how I'm doing so far. I need to get clock and data over there, which is going to be interesting. So let's go back to our tiny traces. See if I can give myself a buffer of 1 pin, because I really don't want this sitting right next to the SPI lines. So let's buffer that 1. Let's come at it like this. Try to hug this a little bit more. Don't shove. Okay, that's fine. Okay, then the tricky one is going to be getting SWO up there. Oh, no, reset too. But that's not a very fast signal, so I'm not worried about it terribly. So let's bring you around here. I don't know what this pin is, but it's not going to get a lot of love. So SWO needs to come from here, interestingly. Don't think I can shove it in there. So what I'm going to do is I'm going to bring it up to here. We're going to come up here, and we're going to put... I'm going to put a nice little via over here. And there's a ground on either side of that via, so I'm not too worried about it. Let's fix this because this is a little messy. Just a little closer. Just a little bit of tuck. Nope, nope. Definitely does not like that. Okay, let's get those. So that's our SWO pin as well. And this maybe will end up being an under pin. We'll see. Let's see what you've got, like a little bit of everything, so you really do sort of need to be here. This one's going to be a huge pain in the butt. Let's see if I can't. That's cutting it pretty close with those headers. But the blue is the actual size of the connector. So the connector is actually not that bad. It's worse on the bottom than it is on the top. But I don't really have much else to go. Like, I can move it up here, but then it would make routing everything awful. I could probably hide one. Can I fit one here? I could fit one here. It's nowhere near the I2C pins, which is going to be fun. And I could maybe fit one here. Ooh, I could fit one here. Going to be a nightmare to route, but let's put that roughly even with these. Okay, well, I can live with that, and then that makes this a little less hectic over here. Problem is I then need to also get these signals over here, which is pretty oof. Okay, for now I'm gonna put a front fill of, let's save. Let's put a front fill of 3v3 because I think that may make my life easier. I don't have to worry about running 3v3 everywhere. It's a little better. I thought one of you were the I2C one. Which one of y'all is the I2C one? Three. Waving my connector wand over this to figure out where the... Did I not connect any of the PMods to I2C? I could have sworn I did. I2C. 6, 11, 16. 6, 11, 16. You are probably just complaining because I don't actually have those connected yet. But you should be connected. Okay, let's... Oh, yeah, it wasn't connected for some reason. Update PCB. Okay, there we go. So I've got to get this over here. I'm still not convinced I want this, but we'll see. So far, things are looking pretty manageable, so... good little friends, the pull-up resistors. Let's do clock closer because that's going to make my life easier. I probably could get a smaller resistor footprint, but I just grabbed what looked like standard-ish. So now what I can do is on the bottom, that is too large. I can connect you here. And I can connect, no. Well, let's do this on this side. Okay. And then I do also need to bring SDA and SCL up here. Clock is on the right. So actually, yeah, that should be fine. I can do... And then data I can do up here. It's kind of a gnarly trace, but you know. We're not putting this through RF testing, so... Let's also take... Let's see, I've got RX on the left. Okay, so that actually works out really well. Let's see, or is it going to be easier to just bring that down? I don't think I'm going to be able to fit 2 through there. Let's just place it. Let's not get too greedy. Let's just see how it turns out. Can I shove through here? No. Might as well put both of those up above. I don't see a need for it to squiggle through. I'll save that space for something else if I need it. That's a choice, KiCad. That is a choice you made.
You've been cooped up inside this tiny little apartment, perking up at all the passing cars. Never warmed up to me or anybody. Jenny said she found you by the side of the road. When she was out of town, took care of you like my own. But now I'm
Yeah, these are going to be fun ones. This scrambling this I squared C all over the board is going to be a big old spider web of I squared C, which I'm not super duper a fan of. But we'll see how it goes. I wonder if it's better if I just sneak down and around.
oh, a better cat I'm never gonna find. Oh, Priscilla, you're a walking, living shadow. Two bright eyes, watching the world go by. Oh, Priscilla, never been in a meadow. Oh, I'm moving out, so I guess this is goodbye. Oh, Priscilla.
Why are you not finding... because ground is not a thing on the top plane. So what I'm going to do is I'm going to place a zone here on front copper, which is ground, which has a priority level of 1, which is okay. And let's include our good friend... this whole connector. And then it's still going to complain because there's no actual ground plane there. But let's do the same front copper, ground, priority level 1. Okay. And then place via... No, I sure don't want a 3-volt via. Thank you. Actually, that's not going to work, so let's just place some other vias. We'll get a little bit more creative over here. And then now it's complaining because that's kept out, but that's okay. What I basically need to do is I need to... No, that's too much. Let's add ourselves a 0.5 then later. Is that the size that I need for this? I can't remember. Yeah, that's reasonable. Come on, I thought the top layer was 3v3. It's probably telling me that there's an island somewhere. We'll figure that out in a bit. let's go ahead and let's get a nice chunky via. So what's the problem? The problem is this doesn't have a 3v3. It's actually not a problem that this doesn't have a 3v3. Well, it will be, but not immediately. Because I could fix that with... like that. And I should be able to place this like that. Which is correct, because my 3v3 is there. Problem is this has no way to 3v3 because... So what I'm going to do is on the bottom, let's get a nice healthy 1 mil track. And you probably should be a chunkier. I guess that's only a reference. That's not really a power thing, so it's not a big deal. Three v3 is maybe a little messy at this point because it probably spiders all the way around, but I guess it is connected on both sides of the board. Although this 3v3 is pretty split up, I may actually want to... I may want to reconnect that a little bit. And I need to get 5 volts over there, which is going to be annoying. Oh, and I've managed to cut out 3 volts as well. How am I gonna get... I guess I could be really jank and run clock way back up here. Or I can try and sneak it through up here. I guess if I move these all down a little bit. If I move reset, tell you what, yeah, let's move reset. Because then I have fewer things blocking me, and I'm not too worried about reset. But I do want this to be the shortest path possible, because I don't want a giant cut across my ground planes. But I could... Oh, I guess that's where it was before. But if I run it... What if I run it... No, not on this layer. On this layer. I run it here. Okay, now that frees up my I squared C to go a little bit less. I guess I can fit two things through here. My wife is struggling with the dog, who is very intent on alerting us that there's someone at the door, even though she just knocked on the door herself. It's the perils of having a very active dog. Come on, let's nice and gentle. Okay, that wasn't terrible. Yeah, I like that. That's good. It's a little rowdy. I could probably clean it up a little bit, but I'm not terribly worried about it right now. And I still have lots of GPIOs that I haven't connected, which is nice. Okay, I'm gonna turn my camera off and just work for a little bit. I'll jump on if I do anything interesting, but feel free to ask questions in the chat. I'm still here. I'm just gonna turn my camera off. So real quick, I realized that I never hooked up the I2C reset and interrupt lines, and before I get too crazy with routing, I should finish those off, because otherwise I have unpopulated pins. So I just looked at the schematic and realized I had two convenient little pins here, so I'm going to connect those over to my I2C.
selection be damned, I'll be okay. I used to think I'd wanna be a bird of paradise, but now I'm happy being just a quail. I used to think I'd wanna be a bird of paradise, but now I'm happy being just a quail.
Okay, well, I'm going to drop out for a little bit for lunch. I'm probably going to be gone for about half an hour. What I'm going to do is I'm going to play the latest episode of the Chats with James podcast. So if you want to keep listening to me talk a little bit, you're welcome to. Otherwise, probably about 35 past the hour, I'll be back. 35 past the hour, I'll be back. And I will, yeah, I'll end up we'll continue on this board. I'm getting pretty close to being done with routing it, so then we're going to clean up the silk screen and we're going to publish it. But yeah, I'm going to take a good 30 minutes for lunch here, and I will be back in a bit. Okay, let me get my face going again. Okay, so I had lunch. I'm coming back. I'm gonna finish this. So where were we? I was routing some lines, trying to figure out a nice, smooth way to get this over to this absurd connector of mine. So I'm just going to continue that. Shove routing is nice, but I wish it automatically snapped back if I didn't. Arg. That's as close as I'm gonna get. And then I need to get this one across. Ugh. This actually needs to be like up at the top. So actually, let's pull our same trick here. I could probably nudge these all closer to each other by scooting these back. Okay, so I realized that I'm kind of cutting my board. Like, I'm a little bit worried about this 3 volts here. Because the only connection to the 3 volts for this header is this little via, which isn't a problem as long as I'm not drawing a ton of current, probably, but I'm still not in love with it, and I'm not quite sure how I can improve on that. The problem is this 5 volt is like cutting in between these two 3 volts, but I guess I could run another via up here. Yeah, let's do that. Let's do that. And then I'll be happy. I need one of my chunkier vias. Kind of cutting my ground off, which is a little problematic, but I do have a through hole here, and all of these are acting as through vias, as well as all of these, so my ground's not too bad. I don't like this gap so much either. Do you have any techniques for post on the design? I had seen, for example, Ben Heck printing out an A4 as a minimum verification before it was shipping to PCBWay or other company to produce. That's a really good idea if you have footprints you haven't used before, like if you have circuit components that you're putting on here. This one's pretty much just a breakout board, so for this, like, everything is just regular headers or connectors that I've used before, like these the quick like JST connectors and the Ethernet connector and the black pill connector. So if you were using a new component, I definitely recommend it. Other than that, yeah, probably not anything that I'll do for this board, but in the future I'll probably take a look at that, especially if I start using components that I haven't used before. But yeah, that's a good question. I typically just kind of fire them, and they've tended to work out so far. But I've also not done very complex boards. But that's a very good idea to print out your board, or print them out and look at the components on there, because sometimes you can order the components in just the wrong size, and that's really annoying because then you have to wait like a week for new parts to show up. But yeah, that's a really good idea if you have like surface mount components and stuff like that that you're not sure of the size of because you've maybe never used them before. So I'm just gonna kind of like tweak some stuff now. Actually, you know what? Before I get really crazy on the tweaking, let's go ahead and do our remaining GPIOs. So let's leave this for now, and I'm not gonna. It's complaining that the 5 volt isn't connected to the 5 volts, but it's connected on the board itself. I think I just need to tell the footprint that they are the same. I just need to fix that in the component itself. But other than that, we should be good. So let's. Okay, before I spend all the time just perfecting that, let's go ahead and hook up our GPIOs. So I'm just gonna generally okay, which one's on the left? Front silk screen 1914.9. 1914 lines, place text left, just so I don't forget. Let's see. Do I want 12 GPIOs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can get 12 GPIOs pretty easy, but then I probably also want to have some power and ground there. Okay. Shouldn't have done this. This was obnoxious. So we have someone in chat asking, is there any good starter project to work on KiCad? I was thinking on taking inspiration from the AT Tiny boards and focus on the power supply and peripherals. Would that be a good start? Yeah, I think doing like little like through-hole breakout boards is awesome because if you could wire it together by hand with wires, pretty much anything you do in the circuit board design is going to be fine. Like you can get away with a lot, especially if you're not doing anything high speed. It depends on what you're most familiar or comfortable with. I mean, like for me, I tend to think in digital stuff, so I haven't done a lot of like analog components and stuff like that. But if you're more comfortable with analog circuits, I'd say feel free to build something. I mean, I'm gonna show what it takes to actually get this circuit board made, but I mean, like the circuit boards are cheap, especially if you're not doing assembly. And yeah, I mean, if you don't mind waiting a couple weeks for them to show up, I mean, they can be, pretty amazingly cheap. So I'd say just make a couple things and go for it. I mean, for me, having the actual circuit board in hand is super nice. So I mean, I'd probably suggest start with something that you know how to breadboard and get it working on a breadboard, and then build a circuit board for it and assemble it on a circuit board and see what the process is like. But I generally suggest something like, not super high speed, not super sensitive analog stuff, but at least for me, like anything that I could do on a breadboard or on a proto board or something like that. It's just generally easier to do it in KiCad because instead of having to like keep track of where all your wires and stuff go, you just have, like a rat's nest and stuff like this where it'll tell you when you screw up and stuff like that. So I'd say just definitely go for it. Okay, so let's get my camera on. So I got a couple questions from chat. Could you expand a bit on the costs that usually go into this process, iterations of revisions, and what are the most usual mistakes particularly? I am not an expert circuit board designer. I am very much a hobbyist, so I've definitely made mistakes. It's always different little stuff, so unfortunately I probably can't give you a great answer for that. For me, it's usually like connecting things to the wrong pin, or like usually it's like schematic mistakes, or once or twice I've had like a via that didn't actually connect. Yeah, the cost that goes into it, I mean, it's the cost of the boards. I use JLC PCB usually. And you'll see the costs. I'll actually price out this board and have them make it for me so you can see what the cost of this is. Parts are usually about the same. Assembly costs a little bit more. But it's pretty close to the cost of parts, honestly. So it's not too expensive. The biggest thing is you usually have to have at least 5 boards built. If it's just circuit boards, you can do 5 boards built, and then if you want to do components, you can, I think it'll let you do 2 instead of 5, so you'll get 5 circuit boards, 2 of which have components on them. But this one's just going to be a circuit board, so it's just going to be the cost of the circuit board. And usually by the time you put components on there, I guess I've never built something really fancy with really expensive components on it. I usually just have like resistors and capacitors that I didn't want to solder myself. So for me, the cost of doing 2 boards versus 5 boards isn't usually that much different. Maybe like $5 or $10. But yeah, if you have to do a couple boards, obviously it's going to cost a bit more. I tend to do pretty simple stuff, so it's not too bad to get right the first time. If I was doing much more high speed or digital or analog or stuff like that, I could see it being much more complicated. But I tend to do really simple boards that are just like kind of circuit boards instead of proto boards, so I haven't gotten anything too fancy yet. This is a lot of wires, but it's really not anything complex. I'm just hooking up a bunch of, pin to pin, pin to pin, pin to pin. Nothing super fancy or expensive. But yeah, I'm getting pretty close to the end. I've been going for like 4 hours, so I'm getting a little tired now. So I'm going to clean up the silk screen. I'm going to make a pretty silk screen now, and I'm going to order the boards, then I'm going to be done for the day. This has been a long stream, so it's probably telling me, unless I'm doing much simpler boards, like simple little breakout boards, I'm probably going to need like 2 sessions to really build a board, but we'll see. Maybe I'll have some simple boards in the future, or I'll just use 4-layer, because it's always easier to route things when it's 4 layers, because you have more options. But yeah, I'm gonna push through, get the silk screen pretty and done, do one kind of final review, and then I'll show you what it's like to order this from JLC PCB. Yeah, thanks to everyone who stuck around. Feel free to keep asking questions in the chat. I'll probably answer them whenever I'm done with the silk screen, and I'll hope you're enjoying the music. Okay, so we're pretty close to done here. Yeah, so I've got everything. There's I just ran design rule checker real quick. And it's giving me some complaints about courtyards overlap, but that's okay because I have a couple of like footprints stacked, and yeah, that's fine. And it's complaining about my one unconnected item, which is 5 volts, but that's because I have it connected on the board itself. So I know there's a nice way to fix that, but I'm not going to deal with it today because, I don't know. If you know how to fix that, I think I just need to change my symbol so it's shows up different. But the last thing I'm going to do is I'm going to put my name on it one more time. No, not on the copper layer. On the back silk screen, place text. Bit shift mask. Okay, let's save that and let's take a look at our board. And we're gonna change some display options. Render options, material. Where's my choose colors? Silkscreen color, define colors. No, I want choose colors, solder mask color. Cause I'm gonna make this a blackboard. Doesn't actually look very much different. I guess it already was black. I guess green would be much more green. They do end up looking much more black actually. I mean, I have some of my boards here. You can't really see the traces in green like you can here. Yeah. That's a board. Pretty happy with it. I got my Ethernet debug header up here. I've got, you know what? Just because I'm paranoid, I'm going to go check this. Open recent. Schematic. Yeah, that's fine. Let's go look at that. Connector. Amphenol 54602. Amphenol 64. $54,602. Yep. Okay, so I am using the part that I know. Okay, so we've got our quick connector up here. We've got a quick connector down here. We've got our SPI port that's fairly readable. CTS, TXD, RXD, RTS, ground 3v3. We've got our everything connector here that's got one of everything on it. We've got pull-ups for our SDA and SCL. We've got our I2C lines. We've got our GPIOs. I did at the last second realize that I had used a GPIO that was actually a USB port, so that it was A11 and I moved it over to A15. I also went and added like a spare parts connector because I realized I had 4 GPIOs that were pretty easy to route, so I just went ahead and gave them 3 through holes, and if I really need to solder onto them, maybe someday I will thank myself. I didn't feel like salvaging that B4, B5, or any of these C. I think 2 of these are connected to LEDs on the board. So I just kind of gave up on those. Someone's asking, is there a PCB provider that's based in the EU? Yeah, Aisler, AISLER, is the one that I know of. I haven't used them before. Maybe I'll order these boards from both them and JLC PCB just to see how it goes. But I've just used JLC PCB a bunch before. I just have figured them out is basically the reason why I keep using them, is because I know how to sort stuff up with them. So I think this is everything. I think I'm going to call this good. On my front, I've got the debug connector with an example of this. I should probably add a note on that. Can I fit this in there? Nope. Yeah, that's fine. Okay, so I've got 5 VO or SWO jump. I've got my quick, I've got my connectors. I've got board design weekend, WeAct, USB-C pill, brickboard breakout. This JLC, JLC charges you more if they don't want to put like a board code on it. But if you give them 4 JLCs, then they will put the board code there. And since this is underneath where the black pill is going to be anyway, whatever. On the back, I've got kind of a key of what all of my pins are. So if I'm sitting there with one board and I'm trying to wire it up, I could just look at the back of another board. I've got a jumper that lets me switch between 5 volt or SWO on my debug pin. Yeah, that's really it. That's a board. That's like, I'm like 6 hours in, including a lunch break, but I'm gonna go ahead and call that I'll call that done. So let me go to my board complete, pre-export. Let me do a dummy check real quick. So these are going to be going outwards. These are going to be outwards. This is going to be a top mount. I checked the vertical height between this because I'm going to use a little like IDC cable here, and I've got at least 3 millimeters of clearance there, so I should be fine. I do wish I had more grounds there. Oh well, problem for signal integrity James later. I'll just lower my clock speed. Debating whether I want to do a level shifter for stuff. No, I'll be fine. I'll be fine. I'll be fine. It's done. This is an all passives board. I'll do another one where I just do a tiny little level shifter and make 1,000 of them and never have to order them ever again. Okay. So how do we export this now? Good question. Since we're not using components or anything like that, we're going to be skipping one part of it, because we don't have to worry about the position files where the components go or the bill of materials. So this is just a board, so this one's actually pretty easy. So we go to plot. We do not use the extended X2 format because JLC apparently has a problem with that. Boards. How did I do it for all the other ones? I put a Gerber's folder. So let's make a new file called Gerber's. We'll use the Gerber's folder. We'll use a path relative. I want all of my layers on here. I did round my corners. So I plot, And I generate my drill files in the Gerber. And honestly, that's about all we have to do. Exclude pads from silkscreen. Do not tent vias. Check fill zones. Boards, black pill breakout. So in Gerbers, I take everything and you compress this to a zip. Create. And then let me open up JLC because I'm going to have to log in. Okay, so this is the JLC PCB website. I'm logged in, so I can go to order now. I can add a Gerber file. Hardware, brick mount. Put this back up. Boards, black pill breakout. Gerbers, give them the zip with all the files in it. And it'll take a second to think. Okay, it's 2 layers. It's 47 by 79. That makes sense. I'm gonna do 5. I'm gonna do black solder mask because I'm fancy like that and figure, or you know, should I do red, green? Tell you what, if you are in the chat right now, you can vote. If I don't hear anything in the next like 30 seconds, I'm gonna pick black. But if anyone feels strongly about green, red, I don't really like yellow, blue, or white, let me know, and I will order whatever anyone in chat says. I'm going to do lead-free, no gold fingers, no, castellated, specify a location. I am going to do panel by JLC. And I want 2 by 1. Well, hold on, let's do that. So this is $681 for 10 boards. If I do single PCB with 10, that's $5. So I'm just gonna do that. I'm gonna do 5 separate boards. How many do I have? I have 1, 2, 3, 4, 5. 1, 2, 3. All right, let's do 15. If it's not more ridiculous, then I'm gonna do 15. It's fine. It's $8. Okay, I haven't heard anything in chat, so we're going with black. I think that's all I really need. Specify a location. Don't have castellated holes. Okay, so save to cart. And I realized I was muted for part of that. But yeah, I'm just saying it was like 18 euros total. Shipped, it'll be here in like 2 weeks if German customs isn't too ridiculous. So thanks everyone for watching for an incredibly long stream, and I will catch you all next weekend for hopefully a much, much shorter stream. All right, talk to you all later.